Algebra 2 Honors, Lesson 6.4, Completing the Square. We're still solving quadratics. So, how do you find the roots of this? Well, if you recall, we set it equal to 0. And whenever we have a square, to get rid of it, we take the square root of both sides. X minus 2 equals plus or minus 0. In this case, we don't need the plus or minus because 0 is 0 either way. So we get x minus 2 equals 0, x equals 2. This is actually a fairly poor example, but it gets the point across. This is called completing actually the square root. I don't know, solution, something like that. I'm not really a stickler for the perfect words. But you take the square root of both sides. It's another way to solve quadratics. So far we've solved quadratics with factoring and with graphing. So this is going to get relatively complex, but if you understand the concept behind it, not that bad, not that hard. Because sometimes it sets up real nice, like x squared plus 10x plus 25. So you look at that and you say, this is the same as x plus 5 squared, and 16 is a perfect square root. So we take square root of both sides. We get x plus 5 equals number one most forgotten thing, x plus 4. So x plus 5 equals 4, or x plus 5 equals negative 4. X equals negative 1, x equals negative 9. Those are our two solutions. You can plug them back in. 1 minus 10 is negative 9, plus 25 is 16. That works. 81 minus 90, negative 9, plus just did that, same thing, works. I won't check it every time in the video, but you should every time you do a problem. So what's the quadratic function with the roots? X minus 1, x equals negative 1, and x equals negative 9. Well, some people would say we could go x plus 1, x plus 9, y equals, FOIL it out, x squared plus 10x plus 9. And if you look up here, we just subtract 16 from both sides. That's what we would get. So you can see that they're all tied together. All of this quadratic material is tied together. So here's another one. X squared minus 6x plus 9 equals 8. Well, again, this one sets up fairly nice because I know the left side's x minus 3 squared. Now the right side is not a perfect square, so it's going to get a little ugly. X minus 3 equals plus or minus square root of 8. Now, normally I would have done square root of 8 in one step, but trying to be nice. X minus 3 equals plus or minus 2 root 2. X minus 3 equals positive 2 root 2. X minus 3 equals negative 2 root 2. X equals 3 minus 2 root 2. X equals 3 plus 2 root 2. Want to save yourself some time? Could have just gone right here and said 3 plus or minus 2 root 2, which looks a lot like the quadratic formula style we're going to use fairly soon. Those are not hard problems. But we'll give you some hard problems. Complete the square to solve. Doesn't set up nice. There's no perfect square on the left side. So I have a whole process I go through. First things first, move the 20 over and write it just like I show you. leaving a big old gap there. Take the 8, the b value, divide by 2, we get 4. I like to put it in a box to save for later. Take the 4 and square it, we get 16. We have to add 16 here to create the perfect square. However, there's an equal sign. If we're going to add it to one side, we got to add it to the other. Can't just decide for the fun of it to add it one spot and not the other. What's in the box? Plus 4. We've just set it up to do that. I usually very carefully color coordinate this. X plus 4 equals plus or minus 6. Now, since I don't have a radical, I'll break this into 2 parts. Otherwise, I would have just kept it simple. X plus 4 equals 6. X plus 4 equals negative 6. X equals 2. X equals negative 10. That's it. Follow the steps and you'll be fine. So here's another one. It's already set up nicely for you. However, it's got a fraction, so this is going to be challenging. Take the b value, divide by 2. Now, I'm writing it twice. There's really no reason to. Put it in the box. Take what's in the box and square it. And that is what we add to both sides. The left side is set up. I don't even have to analyze it anymore. It's just what's in the box squared. And the right side looks like it might give us a little trouble. Negative 24 plus 9. It's going to be a slightly ugly answer. Negative 15 over 4. Notice it's a negative, because when we take the square root, we got a problem. Can we take square root of a negative? Not in the real world. We'll have to go complex. X minus 3/2 equals, careful now, I for the negative, root 15 on top, 2 on the bottom. Don't forget your plus minus. I'm not going to break it into 2. X equals 3/2 plus or minus I root 15 over 2. X equals 3 plus or minus I root 15 over 2. No real solutions, but these are our 2 imaginary roots. I believe they're called complex roots. One last one. This has got the potential to get very ugly because we have a 2 out front. But that's no big deal. Just divide everything by 2. Be careful. There's going to be a point in the very near future where we have to factor that. But here we can just divide. It's not a problem. And now we're right back. As I like to say, the desk is on fire. Now we just have to follow the steps. Oof, boy, this is going to be ugly. Add 25/16 to both sides. By the way, we have to be a little careful here. We're not double checking our work. We're kind of blindly following some rules, so you have to be careful. If you wanted to double check, this would be the spot to do it. Negative 5 over 4 squared is 25 over 16. Negative 5 over 4 plus negative 5 over 4 is negative 10 over 4. That's negative 5/2 x. I got to add these. I can do them in my head, but I make way too many mistakes, so I'm knocking them out in a calculator here. I get 1/16. Yeah, that makes sense. Square root of both sides. X minus 5 over 4 equals plus or minus 1/4. I'll break it into 2. X minus 5 over 4 equals 1/4. X minus 5 over 4 equals negative 1/4. X equals 3/2. X equals 1. Yep, looks good. Let's check 1, see if it works in the original equation. 2 minus 5 plus 3 is 0. Yep. I'll assume 3/2 works, but I won't check it because I didn't actually check it. Putting a square is a very handy skill in terms of solving quadratics. There's a lot of better ways to do it. Graphing is nice, and the quadratic formula, which we're going to do in a next lesson, is very nice, but it's a handy skill because it'll be used in conics. It'll be used later when we put things in vertex form, so on and so on. So make sure you know how to do it. Good luck.